Hello everyone, welcome you all to this video lecture. This is Selva Brinda, Assistant Professor, Department of Artificial Intelligence and Data Science from Ramco Institute of Technology, Rajapalli. Today we will be diving into one of the fundamental sorting algorithms in computer science, that is quickshot. So here we will understand how the quickshot works and how to implement this algorithm. So we will start with an overview of the algorithm followed by a step-by-step walkthrough of the partitioning process. So what is quickshot? Quickshot is a recursive sorting algorithm. This algorithm is based on the divide and conquer method. So initially it picks an element as a pivot and partition the given array around the picked pivot element. So it does so by placing the pivot in its correct position in the sorted array. So how the quick sort works? So initially it picks the pivot element. Then it takes two variables to point left and right of the list, excluding the pivot. The left will point to the lower index and right will point to the higher index. Now move all elements which are greater than the pivot to the right partition. Then move all elements smaller than the pivot to the left partition. Now, let us see the working of quickshot algorithm with an example. So initially we have an unsorted array consisting of 7 elements. So we have the elements like 7, 1, 3, 5, 2, 6 and 4. So first step is to determine the midpoint of your search space. So for that we have to place the index for all the elements present in the array. So we have 7 elements and we are giving the index starting from 0 to 6. So we are going to place a variable called S and E in order to find the midpoint. So we are determining the midpoint of the search space to find the pivot element. So S is nothing but the starting point and E is nothing but the ending point. So calculation of midpoint is done using the formula floor of S plus E divided by 2. S takes the value 0 and E takes the value 6. Now we have calculated the midpoint value as 3. So the element that is present in the index 3 is considered as the pivot element. Now we have chosen the pivot element. Then we have to replace the variable S and E by the variable L and R. So L search for an element that is larger than or equal to the pivot and R searches for an element that is lesser than or equal to the pivot. Now here L finds an element 7 from the left which is greater than the pivot element. Then R finds an element 4 from the right which is smaller than the pivot element. Now L and R can swap each other. So swapping happens now. So 7 is replaced by 4 and 4 is replaced by 7 now. Then L moves one step forward and R moves one step backward. Now L searches for an element that is greater than or equal to the pivot. So it finds an element 1 which is not greater than the pivot or equal to the pivot. Now L moves one step forward again. Now also it finds an element 3 which is not greater than or equal to the pivot. Now again L moves one step forward. Now it finds an element that is equal to the pivot. So 5. Then same way R moves one step backward and find a smaller element or equal element to the pivot. So now R is at a position 5th index position and it checks the element 6. 6 is not less than 5. So it moves one step backward and now it finds an element that is smaller than the pivot. So here the element is 2. So L and R gets swapped each other. So of course 5 is an element from the left and 2 is an element that is observed from the right. So swap L and R. So now swapping happens. So 5 is replaced by 2 and 2 is replaced by 5. Now L moves one step forward and R moves one step backward. So when L and R crosses each other, the partition game ends, which means we are trying to partition the array now. So now the variable L is replaced with a variable called index. So from the index till the end of the array is considered as right partition, and the elements that are before the index is considered as the left partition. So now finally we have partitioned the array before and after the index. So now take only the left partition and check whether all the elements are in sorted order. So the elements are not in sorted order. So we have to follow the procedure what we have followed before, and we have to rearrange all the elements in the left partition in an ascending order. So we have four elements in unsorted way. So 4, 1, 3 and 2. So now place the index 0, 1, 2, 3 above the elements. As usual, same procedure. We are going to place the variable s at the starting point and e at the ending point. So s indicates the element 0 and e indicates the element 3. So the formula is midpoint is equal to floor value of s plus e divided by 2. So s is replaced by 0 and e is replaced by 3. Now we have found out the floor value of 1.5, which can be 2. So the element that is present in the second index is considered as the pivot for this left partition alone. So don't care about right partition as of now. So we have find the pivot element. Now S and E gets replaced by the variable L and R. Now L searches for an element that is greater than or equal to the pivot. So it finds the element 4 now. Then R searches for an element that is smaller than or equal to the pivot. So it finds an element 2. Now L and R get swapped each other. So swapping happens. Now 4 is replaced by 2 and 2 is replaced by 4. Then L moves one step forward, again searching for an element that is greater than or equal to the pivot. So now it finds an element 1 which is not greater than or equal to the pivot. Then L moves one step forward. So now it finds an element that is equal to the pivot, that is 3. Now R search for an element that is smaller than or equal to the pivot. Now R is at third index which contains the element 4 and it is not less than or equal to the pivot. Now R moves one step backward. So now R finds an element that is equal to the pivot. So both L and R are at same position, which indicates the element gets swapped by itself. So now swapping happens, 3 gets swapped by itself. Then R moves one step backward and L moves one step forward. Now, when R and L crosses each other, the partition game ends. We need to partition the array now. So L is replaced by the variable called index. So from the index till the end of the array is considered as the right partition, and the elements before the index is considered as the left partition. Right? So we have two right partitions and one left partition alone. So take the left partition and check for whether all the elements are in sorted order. No, all the three elements are not in sorted order. So follow the same procedure what we have followed before and sort these three elements 2, 1 and 3. So now place S and E over the 0th index and second index. Find the midpoint value. So same formula, and we have found out the midpoint as 1. So the element that is present in first index is considered as the pivot element. Now replace S and E by L and R. L searches for an element that is greater than or equal to the pivot and it finds an element 2. And R searches for an element that is smaller than or equal to the pivot and R finds an element 3, which is not smaller than the pivot element. So R moves one step backward and now it searches for an element that is smaller than or equal to the pivot. As it's find an element 1 which is equal to the pivot. Now R and L get swapped each other. Yes, L finds an element from the left as 2 and finds an element from the right as 1. L and R get swapped each other. Swapping happens. 2 is replaced by 1 and 1 is replaced by 2 now. Then R moves one step backward and L moves one step forward. So here L and R crosses each other. So here the partition game ends. Hence we need to partition the array. L is replaced by the variable called index. So from the index till the end of the array is considered as the right partition and the elements before the index is considered as the left partition. So as of now we have three right partitions and only one left partition. So take the left partition alone and check whether all the elements are in sorted order. So here in left partition we have only one element. So we have to confirm whether that particular element is in correct position or not. So for that we have to place S and E over the zeroth index. So here S and E both are in the same index, which indicates the element 1 is placed in its proper position. So now we can add the element 1 to the sorted array. Next, take the other right partitions. We have three right partitions. So take the first right partition, which consists of an element 2 and 3. So follow the same procedure to find whether both 2 and 3 are in proper position. So we have to place variable S and E over the index 0 and 1. We need to calculate the midpoint value. So the midpoint value is calculated as 0. So the element present in 0th index is considered as the pivot element. So now S and E gets replaced by L and R. So L searches for an element that is greater than or equal to the pivot. Yes, L finds an element 2 which is equal to the pivot. Then R searches for an element that is smaller than or equal to the pivot. But R finds an element 3 which is greater than the pivot. Hence R move one step backward and now it finds an element that is equal to the pivot. Now L and R both are in same position. Then 2 gets swapped by itself. So now swapping happens. Then R is retained in its place. L moves one step forward. When R and L crosses each other, the partition game ends. Now L is replaced by the variable called index. So from the index till the end of the array is considered as right partition and the elements before the index is considered as the left partition. So partition happens. We have three partitions as of now, right partitions and only one left partition. So take the left partition and check whether that particular element is in proper position or not. So for that we have to place the variables S and E over the element 2. So S and E indicates the same index. So this shows that the element 2 is placed in its proper position. So add the element 2 in the sorted array. Then take next right partition, that is 3. So here also the same procedure is followed again. S and 3 is in same index which indicates the element 3 is in correct position. So include the element 3 in the sorted array. Then take the next right partition, that is element 4. So we need to check whether it is in proper position or not. So for that, we have to place the variable s and e over 4. So both indicates the same index. So element 4 is placed in a correct position. So include the element 4 in the sorted array. So we have sorted array with the 4 elements 1, 2, 3 and 4. Also, we have left with the right partition consisting of 3 elements 5, 6 and 7 now. So check 5, 6 and 7 is in proper position or not. So for that we have to follow the same procedure what we have followed before. So change the index 4, 5, 6 as 0, 1 and 2. Now place variable s over 0 and variable e over 2, starting and ending index. Find the midpoint value using the formula floor of s plus e divided by 2. We get the answer as 1. So the element that is present in the index 1 is considered as the pivot element. Now s and e gets replaced by l and r. Now L searches for an element that is greater than or equal to the pivot. But L finds an element 5 which is smaller than the pivot. So L moves one step forward and search for an element that is greater than or equal to the pivot. Now L finds the element R6 which is equal to the pivot. Then R search for an element that is less than or equal to the pivot. Now R finds the element 7 which is greater than the pivot. Hence R moves one step backward. Now R finds an element that is equal to the pivot, that is 6. So L and R are at same position. So we have to swap L and R. That is 6 gets swapped by itself. Now R moves one step backward and L moves one step forward. So when L and R crosses each other, the partition game ends. So L gets replaced by the variable called index, and from the index till the end of the array is considered as right partition, and before the index is considered as the left partition. So take the left partition and checks whether all the elements are in proper order. So for that we have to again find the pivot element, and then we have to place a variable L and R and search for an element that is greater than or equal to the pivot, and search for an element that is smaller than or equal to the pivot. If the condition gets satisfied, swap both the elements and finally we can get the shorted elements. So now the index 0 and index 1 is considered as the starting and ending position. So midpoint is calculated for the left partition containing the elements 5 and 6. So midpoint formula is floor value of s plus e divided by 2. We get the answer as 0, which means the element present in 0th index is considered as the pivot element. Now s and e is replaced by the variable l and r. Now L searches for an element that is greater than or equal to the pivot. Yes, L finds an element 5 which is equal to the pivot. Now R searches for an element that is greater than or equal to the pivot. Now R does not find any element which is smaller than the pivot element. So R moves one step backward. Now L and R are in same position. So we have to swap L and R with itself. That is 5 gets swapped with itself. Now R retains in the same place, L moves one step forward. When L and R crosses each other, the partition game ends now. So we have to partition the array. So L is replaced by the variable called index. So from the index till the end of the array is considered as right partition, and before the index is considered as the left partition. So we have one left partition and two right partitions now. So take the left partition alone and we have the element called 5. Check whether 5 is in proper position or not. So we place the variable s and e over the element 5. So s and e are present in the same index, and each indicates that element 5 is in correct position. So include the element 5 in the sorted array. Next, take the next right partition. It consists of only one element, that is 6. So we have to check whether 6 is placed in its proper position. So S and E variable are placed in the index 0. So both are present in a same index, which indicates element 6 is placed in correct position. So include the element 6 in the sorted array. Next, we have only one right partition with this, which consists of an element 7. So we have to place the variable S and E over 7. S and E are present in the same index, which indicates the element 7 is placed in correct position. So we can add element 7 in the sorted array. So now all the 7 elements get sorted properly. So this is the final sorted array. All the elements are in ascending order. So to summarize, today we explored the quick sort algorithm, learning how to use the divide and conquer strategy to sort all the elements efficiently. Right? We covered the partitioning process and the recursive nature of the quick sort. Then, quick sort is efficient for large data sets. Also, we can implement quick sort on our own and experiment it with the different pivot selection strategies. Okay, thank you all for your attention and thanks for watching. Have a great day. Thank you.